Our next speaker is Qiao, who will be speaking on Mare domes and Mare Tranquillitatis identification, characteristics, and implications for the oldest lunar volcanism.
So hello everyone, good day and good night. Good to be here to talk about our work on the Mare domes in Mare Tranquillitatis, identification, characteristics, and the implications for the oldest lunar volcanism. Sorry. I'm Qiao from Shandong University at Weihai in China. Mare domes are small and general circular structures with convex upward profiles. They usually have very gentle topographic slopes, and they are among the most common undermember volcanic landforms on the Moon. So, studying their spatial distribution and nature will provide very important information for controlling their eruptive process, magma composition, and also nature of the magma source region, and that improve our understanding of the Moon. Previous works have already identified over 300 Mare domes on the Moon, mainly use telescope and orbital photographies. So why we still looking at them? Because uh, many domes are very generally slow. Many are generally less than 5 degrees, and many even less than 1 degree, so they are not easily identified. Many of the lunar domes can be only detected from images very low sun emulations, but obtaining such image is very difficult and the current coverage is very limited. But now we have very good real data. We have the global coverage, high resolution, and the high precision topographic data, which provide a very powerful tool for identification, identify and study the Mare domes feature on the Moon, like the SLDM topography data calculated from Kaguya TC-DTM and Lunar topography data, which had a resolution about 60 meter and a vertical accuracy of about 3 meter. Shown here is the example. The upper one is the dome identified previously. We can see a very circular feature with a very beautiful subameter pit crater, and showing below is a new dome identified by us. Here is the low sun Kaguya TC image. We can see a rise feature, but we cannot make sure whether it's a dome feature or not. But the topography data and the map and the profile shows clearly the Mare dome. So we started a project to search Mare domes on the Moon are also study their detailed nature. And as the first step of this project, we focus on the Mare Tranquillitatis. For short, I will just call it Mare T, which have many Mare domes and also identified as a large shaded volcano by spurities. We use the SLDM topography data with other topography and images to evaluate the previous versus Mare dome identifications and also search new domes. And then we study the detailed nature of each dome. So here is Mare T is the landing target of the Apollo 11 mission. So it's one of the best studied Mare on the Moon. It has the highest titanium content basalt on the Moon, but it also shows sectional composition variations. So this indicates a very complicated and multi-stage volcanic eruptions. And use crater counting method hasn't at all calculate the age of this Mare basalt. We found that all but only one Mare basalt unit are older than 3.5 billion years old. Put this age in the context of global Mare, we can see that Mare T is absolutely the oldest Mare on the Moon. This picture showing the different age, ages of different Mare units within the many Mare. And Mare T is here. Oh, sorry. So firstly, we use the low topographic data to evaluate the previous Mare identification. There are generally 3 major studies. We confirm some ones, but also reject some some Mare dome identifications. So in total, we confirmed the 93 domes, and we also find 7 possible ones, and 10 are negative identifications. Then we use the topography data to search new domes in Mare T. As a result, we identify 96 new domes and also find many possible domes. So in total, combine ours and the previous identifications, we have 189 confirmed domes, also plus nearly 100 possible ones. So Mare T contains one of the highest density of Mare domes among the entire lunar Mare. This is the area density of the Mare domes in the Mare T. We can say two obviously concentrated areas. One is in the north edge and another in the south region. Here are some examples of the Mare domes in Mare T. We can say some are generally very circular or generally circular, and some are elliptical, or some are generally irregular. Many domes have submit Peter features. Here are the topographic profiles. Then we measure their dome base diameter. We find that they are between 2 and 23 kilometers. This is generally within the range of previous studies. However, our new data, the high resolution topography, enable us to discover many smaller domes. We also measure their height and find they are between 20 and 400 meters. And then we study the submeter Peter crater features of Mare domes. They are commonly, though not always, observed at the tops of Mare domes. Among our domes, we find 124 have submeter Peter features, and over 8 have possible ones, and the others lack of it. And the presence or absence of submeter Peter crater seems to independent from the diameter, height, or shape of the host Mare dome feature. Here's the distribution of the distribution map of the submeter Peter crater identifications. Have different color means different possible ones and confirmed ones, or just absence. Here are some examples of the submarine Peter craters. Some are generally circular, and some are elliptical, and some are more irregular. A very unusual shape of the submarine Peter crater are the very elongated piece. They are very long and narrow. We don't see such shape for Mare domes, but we see it for the submarine Peter craters. We measure their diameter, find they are less than 4 kilometers, and we also plot the submeter Peter diameter against the dome base diameter. Two previous studies have found a linear relationship between the two diameters, but our calculation finds that it shows a very wide range, and we don't have such simple relationship. This is probably because our calculation have very huge Mare dome problem. We have nearly 300 Mare dome, but this two function is fitted from over just tens of Mare domes, and we also calculate their depth and
You're
we
at 8
find
minutes.
okay, and we find that their ratio is their depth over diameter ratio have a wide range, and nearly half are shallower than impact craters on the moon. Another interesting finding is that we found that nearly half submeter Peter craters, their floor is topography lower than the surrounding Mare. This cannot be determined from image data only, and suggests a significant submeter Peter collapse process during the formation of the submeter Peter crater. And then we also studied the composition. We find that they have a wide range of titanium content, but their iron content are really homogeneous. And finally, we also check the age of the background Mare. We find 276 domes are located or just near 19 crater population dated Mare unit, but only one domes are hosted in Mare unit that are over 3.5 billion years old. So put this in the context of the global Mare ages, we can say these are generally contemporaries with the peak period of global lunar Mare, but only span a very narrow temporary, just 1/10 of the longevity of lunar volcanism. This indicates that the small shade building eruption may be a prevalent eruption style in the earlier stage of lunar volcanism. Okay, finally, here are our conclusions. We find nearly 200 Mare domes and another 100 possible ones, and many of them have summer mid-peak craters, and we don't have find a simple relationship between the summer mid-peak diameter and the dome base diameter. And the Mare T is the oldest Mare on the moon, and so this means that small shade building eruption may be a prevalent eruption cell in the initial stage of lunar volcanism. Thank you. I will leave my conclusion here and take questions.
Well, I'll ask, did you have any indication that there may be any smaller scale compositional variations of these domes? You showed the titanium map earlier on and the regional scale, but do we see any small scale variations immediately surrounding these features?
You mean the composing of the Mare and the surrounding Mare? Is that your question?
I think so.
Actually, we have already do that. We find that so we have nearly 300 Mare domes, and we find nearly 30 domes. They have very different titanium content with the surrounding Mare. Yeah, we found some.